The phrase, "the Great Unraveling," perfectly captures the dramatic and often unsettling theories about the ultimate fate of the universe. Cosmologists, peering into the deepest reaches of space and time, have proposed several compelling scenarios for how everything might eventually end. These theories are largely dictated by the balance between the universe's expansion, the influence of dark energy, and the gravitational pull of matter. Here are the leading theories on the end of everything. 1. The Big Freeze, heat death. This is currently the most widely accepted theory, given our observations of the universe's accelerating expansion driven by dark energy. What happens? The universe continues to expand indefinitely, causing all matter and energy to become increasingly diluted. As space stretches, light from distant galaxies becomes redshifted to extreme wavelengths, eventually becoming undetectable. Stars will eventually exhaust their nuclear fuel, becoming white dwarfs, neutron stars, and black holes. Even black holes are predicted to slowly evaporate over incredibly long timescales through Hawking radiation. The ultimate state. The universe approaches a state of maximum entropy, where all energy is uniformly distributed, and there are no temperature differences to drive any processes. It becomes a cold, dark, and empty void, a near vacuum of subatomic particles and photons, where nothing ever happens. To the Big Rip. This is a more dramatic and rapid end, but its likelihood depends on the nature of dark energy. What happens? If dark energy, the mysterious force causing the universe's accelerated expansion, continues to grow stronger and its density increases over time, a hypothetical form called phantom energy, it could eventually overcome all other fundamental forces. The ultimate state. The accelerating expansion becomes so powerful that it first tears apart galaxies, then individual stars and planets, then atoms, and finally even the fabric of spacetime itself. Everything would be ripped apart into isolated, ever-expanding fundamental particles. 3. The Big Crunch. This theory was once a prominent contender but is now less favored by current observations. What happens? If the density of matter and energy in the universe were high enough, the gravitational pull would eventually overcome the expansion. The universe would then stop expanding and begin to contract. The ultimate state. The contraction would accelerate, causing galaxies to collide, stars to merge, and temperatures to rise dramatically. Eventually, all matter and energy would collapse back into an infinitely hot, dense singularity, much like the reverse of the Big Bang. This could potentially lead to a big bounce, see below. 4. The Big Bounce, cyclic universe. This theory offers a more optimistic, albeit speculative, cyclical view of cosmic existence. What happens? Instead of ending in a final singularity, Big Crunch, or an infinite void, Big Freeze/Rip, the universe might undergo endless cycles of expansion and contraction. A Big Crunch would lead to a bounce that triggers a new Big Bang, starting a new cycle. The ultimate state. The universe would effectively be eternal, dying and being reborn in a continuous cosmic dance. This concept often incorporates ideas from string theory or loop quantum gravity, which aim to resolve the singularity problem of the Big Bang. 5. Vacuum decay, the Big Slurp. This is one of the most unsettling and hard-to-predict scenarios, rooted in quantum field theory. What happens? The universe's fundamental fields, particularly the Higgs field, might be in a false vacuum, a seemingly stable, but not truly lowest energy state. If a true vacuum state with lower energy exists, a quantum fluctuation could trigger a bubble of this true vacuum to appear somewhere in the universe. The ultimate state. This bubble would expand at nearly the speed of light, fundamentally altering the laws of physics as it propagates. Inside the bubble, atoms might not hold together, and life as we know it would be impossible. It's a sudden, unforeseen, and irreversible change to the very fabric of reality. Current scientific consensus. Currently, observational evidence, particularly from studies of the cosmic microwave background and distant supernovae, strongly supports the idea that the universe is not only expanding but accelerating in its expansion. This makes the Big Freeze, heat death, the most likely ultimate fate, with the Big Rip remaining a possibility if dark energy behaves in an increasingly aggressive way. The Big Crunch and Big Bounce require a universe with a much higher density of matter than we observe. Vacuum decay remains a theoretical possibility that is incredibly difficult to predict or confirm. The Great Unraveling is thus an ongoing cosmic drama, with scientists continuing to gather data and refine their theories, hoping to one day definitively determine the ultimate destiny of our universe.